Hey everyone, how's it going?
Hey, it's going pretty well. How about yourself?
Good, good. It's been a good day not having to deal with the madness of East Denver. Although I'm sure it's great fun to be there.
I'm actually right there. So if it's a bit noisy when I'm presenting, I apologize in advance.
Noisy is a good sign. That's what we want to hear in community events.
All right, I guess we can probably get started. We do have quite a few items on the agenda. I'm not sure who's from which wallet here. I think there are a lot of new names, but I will post the recording afterwards, so hopefully we'll get some feedback from everybody. So I guess let's get started with All Wallet Devs number 38. Um, Mercy, are you here? No? Okay, so we will come back to that one. Yeah, I guess let's start with the structured data clear signing format, ERC 7730. If you guys are here to give us like a summary, that'd be great.
Yeah, I guess that would be me. So, hi everyone. So very happy to be presenting today. I see that Tariq he has joined also, so I will count on him to back me up when there's any need. Do you know how much time I have to present the ERC roughly?
Yeah,
That
take your
that would be
time.
appropriate. Okay.
Yeah.
So just to give you maybe a little bit of context, I've got a couple of slides that I can share that gives that explains a bit history and the approach we had for the 7730 file. So let me if I can let me share. I don't know if I can share my if I can share my screen.
Oh,
I'm not sure.
yeah, the Zoom bot just joined, so hopefully it'll give me admin here. Nope, I guess not. So, do you have a link I might be able to share?
It's actually a PDF
Ah,
file,
okay.
so. Well, that's fine. I can do it without without the slides. It's
Oh,
okay. So
there we go.
basically, the context of 7730 was to for Ledger, hardware wallet, and wallet to start trying to solve better the issues of blind signing. So how do you actually display relevant information to the user when they actually want to approve a transaction on their device? This is a complicated topic because typically what we realize as wallet maker is that base function call or message call that you make user sign, even if you are equipped with the ABI of the smart contract that you're trying to call, is not really human understandable for many different reasons. The first one is that ABIs are very developer driven. They look like function calls rather than mostly user intents as translated as user intents. And they actually also basically use only the Solidity types, which can actually be formatted in many different ways. So as an example, an integer can be interpreted as a token amount, or can be a date, can be a block height, or any kind of things that make sense for a smart contract as a parameter. And there's no real information that wallet can use apart from the smart contract code itself to try and display this information correctly to end users. So this is the crux of the problem that we are trying to solve with the 7735. So how do we transform a transaction raw data or a message raw data that we are making a user sign into a human readable intent in the easiest way possible and the most scalable way possible for end users? Because just to give you a little bit of context, as Ledger, we introduced roughly a lot of technologies to start doing that actually a long time ago, like 3-4 years ago, mostly based on programmatic extensions to our application that we're running on our wallet. This was a kind of a maintenance nightmare. It required basically dApps developer to understand C code to actually extend anything in a relevant way. Very specific to Ledger, so not reusable whatsoever for other wallets. So that's why we started to introduce 7730 proposal as a standard to have a common approach for clear signing any kind of message or transaction based on a few common concept that we had in mind that would be able to be reusable by all wallets, so that dApp only has to write his 7730 file once and will be clear signed on all the wallets in a kind of a similar standard way, actually. So the base principle, the philosophy behind this standard, we had a few things in mind when we started pushing the standard. First is that it's data driven, so it's actually a metadata file which is appended to the ABI so that it complements the ABI and provide formatting information to the wallets on what they should display to the user when the user is interacting with a specific smart contract. This is the basic idea behind the 7730. It's presented as a JSON file that I'll be able to share some example later that contains this metadata. It's data driven, so I think it's not a programmatic model. It's only providing metadata about how to format each transaction call. There's no logic built in beyond what is specified in the standard itself. Which made it a good support for both hardware wallet and software wallet, given that hardware wallet tends to have far more restriction on the execution capabilities that they have. We wanted a standard that could also be supported by hardware wallets, whatever their form. So that was a fairly important one for us. Obviously at Ledger, I would say, but definitely that was useful because nowadays what we realize is that by being very data driven, it's basically a JSON file. It also plays fairly well with AI tools, and it created a standard that is fairly easily interpreted by AI tools and generated or analyzed by AI tools. So which is a kind of a boon for nowadays, I would say. So the basic approach of the 7735 is that basically if you look at some of the examples I can post here on the this is a typical this one is the main example that you can find on the ERC GitHub, on the Ethereum
You can try
Foundation
sharing your
GitHub
screen
for
again if you
ERCs.
want.
Yeah, that would be let me try.
Or if you have a PDF file, Laurent, you could ping it to me. I might try sharing screen.
Actually, I can you should be able to see my screen now.
Yep, we're all good.
Perfect. So these are the slides, just an introduction. So this is what we call, can you see the slides or do you see the GitHub right now?
Slides.
Oh, Perfect. So just to quickly go through the most important points, this is what we call blind signing. So it's users, they definitely sign something, but they don't understand whatever they're signing because it's presented as a hash. And we want to go basically to an interface which looks a bit more like this, where every field is every field is interpreted and clear to the user. And as I mentioned, the ABI itself is not enough because that's the kind of interface you can build with the ABI itself. As there's a lot of issues, even for the current ABI to interpret the parameters as a user, and it's not really that much better than actually a raw hash that you have to sign because you still have to interpret as a user a lot of parameters that are completely dependent on the program you're calling actually. So you have to build in knowledge in that. So, and as I was saying, these are the requirements we had when we started to introduce that. So data driven, so it's basically a metadata file, human friendly, so it's made to be read by humans with a nice addition that nowadays it's also easily read by AIs. So it's pretty powerful to have kept this requirement all the way through. It's standardized, so we really wanted something that was not specific to a specific wallet or hardware wallet, and that could be reused by all wallets, so that basically the dApps only have to write the file once and be clear signed on all the wallets. And it was very important because the problem of clear signing is really a problem of scale. To describe correctly all the files out there, you have to have the support of the community and all the dApp makers to help us describe what's supposed to be displayed to the user. So we really need to build this standard so that we can get to a scale that is Ethereum scale basically, and not just a couple of wallets trying by themselves to clear sign to boil the ocean of by clear signing just whatever they can actually. And we also wanted something that was easy to implement, or more rather than easy to implement, that was possible to implement whatever your constraints, including the most stringent constraint that wallet could have, like hardware signers that we have at Ledger. So this was some of the requirements we had in mind when we started developing the 7730. And how does it work? As we mentioned, basically you have the standard that is the key component. Then you write a JSON file that contains the metadata about the way you want to format your transaction and messages. And this gets inside the public registry, and we are in the process of transferring this the ownership of this public registry to the Ethereum Foundation. So once this is done, you will submit basically the 7730 to the public registry. And once this is done, this file is actually imported by the wallet, verified, and then the wallet can use it to build the correct user interface actually for that. And what does it look like? Rather than showing an example, maybe I can, let me switch back to the GitHub. It's a bit more clear. So this is an example of what a simple ERC 7730 files look like. There are three important sections to understand in the 7730 file. So the context section here is really all the binding context of when the 7730 file is applicable. So it gives you basically what contract you're trying to interact with, what are the deployment addresses of this contract in the various chains that are EVM compatible. For a message, it will give you the similar kind of information. You can actually add the name of the contract that you want to bind into. In the V1 of the format, we had also the ABI and the schema of the contract here, but we realized that it was better to embed it directly in the display section. So we removed it, and that made the file far easier to read and to manipulate actually. So it's better. Then we have the metadata section, which contains displayable information by wallets on the target of your interaction. So typically information about which contract you're interacting with, which entity behind the contract you're interacting with. Some additional information that might be useful for users, like a URL they can go to interact with this contract. So a dApp URL, for instance, or any kind of information that the owner of the contract might want to show to the user about them when a user interacts with a contract. And then the most important section is the display section. So this display section actually contains the core information about the standard itself, which is the formatting information about a specific function. So here you have, we explicitly name the function that the formatting information applies to. So here it's a simple transfer function for an ERC20 token. You have an intent, which is a verb that represents the intent of the interaction of the user when they're calling this function. And then you have the field section, which describes how to format each parameter of the call, and whether you should display it or not as a wallet, actually. So here you should actually display both parameters. It tells you, okay, the two parameter is actually an address, and you should format it as an address, or as a trusted name if you have a way to transform the address into a trusted name, which can be an ENS name, for instance, or it can be a local address book for the wallet if the user has associated this address with a specific name on his own. So any kind of transformation from an address to a name is acceptable as long as the user or the wallet trusts it, actually. And then the value is actually interpreted as a token amount. That means that basically this integer value is supposed to be converted as a token amount, and by that we mean that actually the wallet should get the token details from the add to parameter here. So basically the destination of the transaction in that case. Use it to retrieve the ticker information and the decimal that the token is using for its values. Convert the value using the decimal and display it with as a real value plus a ticker, so that the user really have a nice experience when they are interacting with this token and don't have to convert themselves the actual integer in the token value. So this is basically the crux of the standard is really there. So we've kept adding new formatters to tackle new use case. So every single time we see new use cases, then we add new formatters so that we can enrich the standard with new interaction supported by the standard itself. So, for instance, recently we've added interoperable address, which was another ERC that was introduced to standardize the way address cross-chain are formatted when as a parameter to a function call, and also the way it's actually displayed. So it was a pretty nice addition to say, okay, we actually this integer value is actually a cross-chain address, and display it as a cross-chain address as specified by the other ERC. I think it was 7930 if I remember correctly. So this is we keep adding new formatters like that. We are at a point where we believe we've covered quite a few use cases, and we are fairly happy with the current forms, which is why we're calling it a V2, at least a draft V2 ready for public review and getting more comments on it. What can I say more about the 7730? We've also added a couple of things that makes life easier for the edition of the file itself. So ways to include files or ways to put in common some definition here that makes it a bit easier for an actual developer writing that file to have a more compact representation of the file. So this is all described in the ERC 7730. But again, the intent was really to have a file that in the end is fairly human readable. So this still looks readable for developers that understand what they do. Easy to write for smart contract developers, and that with what still interpreted completely easily to interpret by wallet, so that they can take this file and enrich the ABI of what the user interact with to actually display the interaction in the nicest way possible that they want to target, actually. So this is kind of the crux of the 7730 presentation of the standard itself. Around the standard, there's another big topic we have in the pipe currently, which is the discussion about the way we do the governance of the registry itself. So as I mentioned in the slide, basically the intent is to put all the 7730 file for now in a GitHub repository. Right now, Ledger is hosting this GitHub repository, but in the coming weeks, it should be migrated to an Ethereum Foundation GitHub repository. But a big part of the job of maintaining this GitHub repository is actually checking that the file that goes in the registry actually corresponds to the implementation of the smart contract that goes on chain, actually. This is very important for the security of the whole ecosystem, and it's the ultimate line of defense in that case is the wallet itself, and the wallet should actually verify that everything goes. But as an ecosystem, it's far better if there's a way to actually verify and audit the file that is in the registry itself and attach to this registry trusted information about who has done the audit, what was verified, and maybe some additional data, so that wallets can take a faster decision on trusting a file or not that is in the registry. So this is a big part that is currently under discussion. So I don't think I think Arik, you had some proposal on that to have a let's say a cleaner proposal on the way we handle the registry when it's migrated to the Ethereum Foundation. But otherwise, these are the big topics. So 7730 is really about the metadata that enrich ABI so that you can convert a transaction or a message into a clear user intent to display to the user. It's a public draft ready for review by the larger community, so that we have the best standard that we can get out there. And then in the pipe, we have this governance to discuss so that we get a system which is as decentralized as possible with as many auditors that can contribute to the reviews so that we can really scale the data that is covered by this standard. That's roughly let's say in 20 minutes. That's a very quick presentation of the 7730 and the ongoing work around it. That's
Thank you so much for the presentation. That's a really interesting proposal. There are some questions in chat, but in the interest of moving to the next the next discussion point, I'm going to hand the floor off to Mercy and get a presentation about RPC endpoint versioning.
Sam, if we can only ask, because I think one of the main purposes of this presentation is two things. One, if you're a wallet and you're thinking, what does it mean for me? Should I integrate this? How? Talk to one of us, right? Lauren, Hester, me, somebody, or just post in like the Nexus group or one of the other ones and reach out, and we're happy to do more specific sessions with wallets and protocols that want to use this, right? So I think this is really, really important. And if you have feedback on the ERC, where we finished a draft, but we're happy to take more feedbacks. So this is really important for us as well. Thank you.
Great, thanks so much. Mercy.
Hello, Sam. Thank you. Good evening, everyone. I don't really have a presentation per se. I just wanted to get more input on this. So the RPC team is trying to explore endpoint level versioning for JSON RPC API. So, and we would really love to get input from wallet devs and users before we finalize what the V1 looks like. So I will share a JIT and its magician link so that to get more points in case maybe if something comes in mind later. So the thing is that we wanted to ask if there are specific methods or response fields where that backward compatibility is critical for wallet devs, or any pain points when the spec changes that we should be aware of so that we don't do something that will break at some point for the real users of the endpoint. So before we finalize version 1, and we would want to get this input first so that we will know what to include in version 1 and then know how to progressively take up from there. I don't know if what I'm saying is making sense at all.
I think so. So you're working on adding versioning to certain Ethereum RPC endpoints, and oh, you're still sharing your screen, by the way. And you want feedback on how that gets shaped?
Yes. Let me share the link, the PR links to get more content.
I pinged Lauren a couple of times, but if you can stop his screen sharing, maybe that's also a good idea.
No, I'm not. I'm technically not. Oh, there we go. Okay. Awesome. Well, thank you, Mercy. Yeah, if anybody has any feedback, please leave a comment on the discussion thread and PR that's going to get posted. There we go. If anybody has any comments now that they'd like to discuss about it, we have a bit of time. Otherwise, we'll move on to the next discussion point.
Okay, so I also want to include, maybe I can share like a call link for the RPC in case something comes in mind, because the idea is to get to address how the breaking change how it's being handled currently, if that is a pain point for wallet developers, and if there's something we need to keep in mind before making this shipping this endpoint versioning, so that it will be useful for your workflows and it doesn't like unnecessarily add a sort of complexity to what we have already. So if it is something that is important or useful, we would like to get an input. And then if it's a pain point or something, maybe you feel like, okay, this needs to be corrected, or there's something that needs to change in the RPC spec, for example. Also, this is like an open floor discussion in general. So because at the end of the day, wallet devs are the main users of RPC endpoints. So
All right. Well, thank you so much. Moving on to the next discussion point, we have another clear signing proposal. Yeah. I unfortunately don't remember who was supposed to present this, but if you're here, please take over and tell us a little bit about your proposal.
It's me, and also Nail on the call. He probably would need screen sharing permissions. Yeah. Hi. So I swear it wasn't scheduled for us to be on the same call as Laurent, but I'm really grateful for both his work and like setting the stage for this. Because in my team we've been using with a very related problem, like not exactly the same, but closely related. And like, yeah, with a little bit of a support from Ethereum Foundation, we now can prepare some early draft of our finding. We're not even like draft of ERC stage, but yeah, if you go to the root of it, our problem is that I'm stupid and stubborn, and because of that, I want to give developers a way to specify how the contracts should be represented in the hardware wallets. And to add insult to injury, the hardware wallet I have in mind is this thing with a ridiculously low bandwidth both on input and output, which is a very different security model from Ledger, and a different set of trade-offs needs to be done. And so, yeah, like we want users to be able to see what they sign. And we want users to be able to see what they sign, even if that's a very, very fresh, I don't know, some sort of a DEG token swap thing, which launched in the last 24 hours. And definitely, like, it's not going to be merged in any centralized registries, even if it's a legit, but that's questionable. So we want that to work in a developer-driven semantics without central repository of truth, which verifies it after them. We want that to work without like real-time dependencies. This thing doesn't have a full Ethereum state, even less it has access to the GitHub with the latest JSON definitions and those constant firmware updates. They are not the sweetest point of Ledger, but for us, with an NFC bandwidth to our device, we just can't have it. So it shouldn't have like any pull dependencies, no real-time communication. It should be like one-way push only for this specific call. And like, yeah, I don't want to be a trusted intermediary. I don't want to hold the keys to the castle and tell that, oh, this contract gets clear signing, this doesn't get clear signing. I ideally want that to be the contract authors. And at the same time, I want to prevent my users from phishing. So like, I don't want a new like address to be presenting itself as a USDT and then defrauding my customers. Quite a lot of contradictory requirements we have there. Oh, and of course we want to have composability. Like since we are talking about like push semantics and developer driven work and so on, I want that to be wrappable in a multi-sig call from my Gnosis safe. Without Gnosis safe or anything down the chain, to have to add additional wrappers for my hardware wallet node to how interpret it and show it, hi, that's a multi-sig call 1 out of 3, which is wrapping this particular transaction to this new Shibu swap thing they just deployed. So I want what we see on the screen, or any screen, like any hardware wallet, maybe software wallets, to be the law. I want us to cryptographically be bound to that law. And we designed with a very different set of requirements, I think, which hopefully extends 7730 with the features which are required to make that possible. Not without its trade-offs, but we will get there in due time. So our first and very basic important assumption is like, everything would work better if we split explicitly social layer and protocol layer. So like social is like the who, oh, I don't want that new smart contract to look as its legitimate USDC. And we sort of solve that by token lists already. And anyone can publish such a list. Let's do contracts lists. Let's extend that to somehow verify the identities by parties you or any wallet developer trusts, and have a wallet level definition for any address. If it's a contract, is it a well-known contract, who owns it, and so on. And the second, let's extend that with ability of a contract author to specify a display format. It is very, very closely related to 7730, but with a twist that our way interpreting that format, interpreting that how to parse that ABI is very friendly to both push-based and composable ways of expressing it. So we want DAP to tell to the wallet as an additional array, hey, that is the extended info you can use to show on screen the human readable parsing. And then the wallet will maybe send it to the signer. So maybe it's a Gnosis safe which sends it to the Ledger Live, and then Ledger Live sends it to the actual hardware device. Or using Wallet Connect, you send it to the mobile companion of this thing, and then you put this thing behind your phone's NFC, and it's also get pushed. And every layer in that chain would just extend the display array, adding additional representative arrays which help you semantically interpret the APIs. I've seen that question in the Q&A, and I would very briefly address. The problem with APIs in Ethereum as it stands is they are not it requires some data which is not on chain to parse what it means. It is not semantically unambiguous, and that can be used against wallet users in very different ways. But the stupidest way is, there are different tokens and they have different decimals. And if you swap one for another and your wallet doesn't know where the decimal is, there is nothing in the ABI call which will tell you if you're swapping 1 or 100 of that token. And if you are presenting that in a human readable form, you will fail. So we pass that through DApp, through the wallet, all the layers to the actual signing device. I'm thinking about hardware wallet, but once again, your MetaMask on the smartphone is exactly the same. You use that additional metadata which we pushed with the call to represent that on screen for your user. Nice thing which we have sort of kept in mind is that it might have different locales, having a Chinese interpretations for the fields might be useful additional to having English language ones. And then you cryptographically commit to what you've just used to show. And with that, you are avoiding all those attacks with developers or someone presenting themselves as developers, pushing a falsified metadata to your hardware wallet. So you signing not what actually happens on chain. We all seen those hacks happening. So this is a legitimate vector of attack. And then you sign that by effectively having a EIP 712 hash struct hashing of what you used to display, all those arrays of meta info for the calls and which instructed your wallet how to parse. And then you effectively wrap your call data with an additional clear call on-chain call, and this is one of the important trade-offs we're currently talking about. So you have a clear call which accepts display hash as the first parameter and call date as a second parameter, and it's a very, very tiny shim. And our benchmark is about like 7 to 8,000 gas units. And what it does, it just compares the display hash with what it has hard-coded in the contract, and it fails if that is mismatched. That means that you've been misled by whoever sent you that meta info, and your transaction is drawn based on wrong assumptions. It should never be accepted by chain. This is how we avoid that single point of failure. And if clear call passes, then we are good. And nice thing about that, it's completely stateless and completely composable, because like different layers of that display logic, they can be assembled all together. And then another important part is like, how do we get from here to there? Because like obviously that requires an on-chain changes, and that's a big ask, and we cannot just move the whole Ethereum ecosystem. So especially for the things like Uniswap, like Uniswap v2 is not upgradable; it's still being used. If you cannot see it on screen in a human readable form, okay, like that was for nothing, because the goal is to never have to deal with like signing those unreadable hashes anymore. So we introduce like interlinkage between the first thing, like the contract lists, and our display format, in the sense that to be accepted to the contract list, you need to verify your identity and somehow pass the like basic checks. And then you can attach those display hashes to that contract list, which is hopefully not updated very frequently. And on another side, like if you're a new contract, of course, you might be able to deliver a contract which has that additional clear call method, which will just enable everything for you magically. And there is the middle ground. Like we want that to be somehow like managed on chain. So like there might be a DAO which manages the mapping between this address and this selector maps to that hash data, and those would be just like wrapped in either like smart wallet call or just a flashbot like assumption. So like here is a like actual call, and here is an assumption by it, and we rely on the flashbots to make sure that externally owned account also get the pre-flight checks before sending it. And that's sort of it. So like our trade-offs are, it either requires a contract changes, or like extending something like 7730 with additional social layer of like, hey, this is the source of a hash data that might be on chain or might not be. Then we have a gas overhead. It is not free. Like we commit and we make a chain check, an additional check. That's just a couple of S stores. That's like we have benchmarks for that. It's 8,000 gas overhead in the current limitation. Might be even tighter, but it is still an overhead. And like, yeah, the last one is developer adoption, and this is why we are on this call, and we really want any feedback which would make that adoption easier. And to prove that it's not just like a figment of my imagination, I would like to give like driver's seat to Nail, who did the most of the actual work, and I just like was running around during this. And Nail will show us hopefully the full cycle of a DApp sending its metadata to the hardware wallet through the like wallet adapter, and then we sign and we send it back on chain. We use a simulated Uniswap, I think, for that demo, if we are ready with that. And like that is a, yeah. Maybe we can see you, but not hear you.
Hello, everyone.
Saying so. Okay, yeah.
1, 2, 3.
Now it works. Yeah.
Hi,
Awesome, thank you.
I'm Nail. My name is Nail. I'm from Kampala. We're working on clear signing architecture, and I would like to demonstrate to you how it may work. This DApp is based on scaffold S framework. I added the Uniswap version to contact with the clear call support, and I like to demonstrate at first how it may work even in your browser or hot wallets, because actually there's no restrictions if it's hardware wallet or mobile wallet or anything else. So we just, it's in swap version 2. We just do a swap. Right now we just show this notification because it's private key stored in browser. We can see one warning. It just our requirements that we want to do because we don't want DApp to hide that some value was set in Ethereum value of transactions. So if it's zero, then we don't show this. And here we can see fields kind of in the same way as 7730 Apollo does. Yeah. So it demonstrates that it's possible to work with this in browser. I implemented Rust library and ported it to browser, to Android and hardware wallet. And next up, I would like to show you a demonstration of Android wallet connected with our compiler hardware wallet. Please, I need more time to switch camera. Yeah, it's here. Let's see. Android device, this is the same app that we had on desktop. Before I create my wallet Android with hardware wallet compiler, and I would like to send transaction. Now you can see that the transaction is parsed and displayed on mobile wallet the same way as it in browser. Right now it uses special native use, so it's not text-based, and this demonstrates how this library can be integrated into native mobile wallets with native use. Now we click confirm and send it to compiler. Let's try one more time because sometimes NFC doesn't accept. Let's see NFC packets. Yeah. Let's see what we have on compiler. Basically, it shows transaction information, swap for F tokens, and all the data that we saw on mobile and desktop. Let's right now need to send transaction to compiler one more time because I disconnected it NFC and power.
Yeah, I want to highlight that there is
That's
no
off.
custom parsing transaction code on the compiler apart from implementing this RFC. So everything we see about like which tokens get sent to which addresses, this call sends real ETH and so on, those are all part of the spec. They are not hard-coded pre-existing knowledge.
Let's click approve. Now it shows transaction encoded. Let's scan it. Yeah, and transaction sent, op, and transaction sent, and balance updated. You can see almost 0.7. Yeah. Yeah. So I wanted to demonstrate. Basically, our approach works well on web, on mobile, and on hardware wallets. So yeah, and everyone can benefit from this architecture. Thank you.
Yeah, thank you. Just to reiterate about how this is like a full cycle. If you are a developer of the wallet, you implement the display format parser. Maybe you base it on the 7730 work. Maybe you do that aside of it, but schema is published, Rust reference implementation exists. You just do something like that. And you start with well-known token lists extended to the well-known contract lists, and you get all those features like those token IDs in the signing pop-up on the Niall's mobile phone. It wasn't hard-coded. It is just in a list of well-known tokens with their identities. If you adopt dev, you start attaching display array to the send transaction call to the wallet when you talk to the Ethereum wallet. For legacy contracts, that will be informational, but if you are a new contract, do the clear call. If you're a smart contract dev, do a clear call if you have existing contracts that work on getting that to the contract lists and somehow publishing your hash for display and their full contents. And for the ecosystem, I wish that would be more work on figuring out how we control those registries and how can we transition from, oh, that's something on Git to something, oh, that's something on chain we can then leverage on the next stage of this plan where we can do the smart accounts wrapping the actual calls in the clear call addendums, or having those flashbot task approaches where even the externally owned accounts can benefit from this without relying on just known parties and instead of that committing to the hashes on chain. So yeah, I want every feedback we can get from the ecosystem. I want that to be ergonomical. I want that to be useful. And I want us to start moving in the direction where we have a very clear representation for our users, what they sign. Because I'm really not happy with the situation we are in right now. Everyone is learning how to sign those hashes. And in the light of every livid user who is doing more than just sending USDC once in a while, that's a fact of their reality. They cannot fully trust the hardware wallet screens.
Awesome. Thank you so much for coming out and presenting. Again, in the interest of time, I think we'll move ahead to the next point and we'll do asynchronous questions on the Discord server or the Ethereum Wallet Nexus Telegram. And with that, I'll hand it over to the last point, which is universal enshrined encrypted mempools.
Hi, everyone. My name is Loring. I'm from BrainBot, one of the core contributors to Shutter, which recently proposed EIP 8105 as a potential Hagota headliner. And my colleague Yannick will be going into some technical details about 8105, and then we would love to get feedback from all of the wallet developers.
Yeah, thank you, Loring, and hello from my side as well. My name is Yannick. So with EIP 8105, what we want to do is add an encrypted mempool to Ethereum with the goal of protecting users from front-running and sandwiching attacks, even if they use the public mempool, which we think is very valuable because users will not have to rely on private mempools anymore or trusted builders for the security of their transactions. Which is good for the protocol in terms of decentralization and neutrality and censorship resistance and all these properties. How it works on a high level is that we add a new role to the protocol called a key provider, and their job is, on the one hand, to provide encryption keys to users so that they can use those to encrypt their transactions with them. And on the other hand, provide, when needed, the corresponding decryption keys to the protocol so that the protocol can then decrypt and execute those transactions. Encrypted transactions will consist of two parts. First, the encrypted payload, that is the actual transaction that the user wants to have executed. And then around that, this is wrapped in an envelope, which is plain text and handles the gas payment. And they get executed in two steps. First, in the block in which the encrypted transaction is included. The plain text part will be executed, so the gas payment, and in a way, this schedules then the decrypted transactions to be executed in the next block. Basically, when a key provider sees the executed envelope, they will then provide the decryption key between the two blocks, and in the next block, we can decrypt and execute. This is basically it from a wallet point of view. I think what has to be done is, first of all, they need to, or you guys need to enable users to choose one of these key providers or choose for them. I think that should be very similar to how a RPC provider is chosen today. Then they need to encrypt the transaction, which is something that will be dependent on the key provider. That might be so there might be some SDK that the key provider provides, or an API maybe, but it's not specified in the protocol. Then the wallet has to do this two-step signing process, basically encrypt or sign, encrypt, and sign again the envelope. And then when you send the transaction, you have to watch for basically two events: one, the transaction being included and the gas payment being handled, and then in the next block, the actual execution. Yeah, I think that's mostly it. Lauren, you wanted to say a bit more?
I think that's a great introduction. We have been speaking with the client teams about how to implement this and been getting wonderful feedback. We also recognize that EIP 8105, once implemented, would impact wallets in a range of different ways, from potentially changing revenue models to new UX flows, as Yannick mentioned. And so we are excited to make as many connections as possible with different wallets, collect your feedback, your suggestions for improvement, your questions, so that we can incorporate that into the EIP itself and make sure that once it is implemented, that it is something which wallets will embrace and actively support. Maybe, yeah, I'll leave it there. And if there are questions and we have time, we can do it on the call, or please reach out to me in the Discord or on Telegram. I'd love to chat with you one-on-one.
Awesome. Thank you so much for taking the time to come out and talk about your EIP. I guess we have 9 minutes left. If anybody wants to chat about anything, feel free. Otherwise, we can end it here. Great. Well, let's call it here. I'll upload the recording to the Discord server. And if anybody has anything to talk about, let me know, and we'll schedule a meeting for next month. Take care, everyone.
Bye.